Okay, lessons 59 through 62. Today, lesson 59 is proportions with fractions. Okay, what does that mean? That means you're going to have some version of a fraction equals a fraction. I'm going to list these things A, B, C, and D. What I'm going to show you how you do this is that if you wanted to find one or the other, what people would normally do is they would say use cross multiply, and they use this idea because B times C equals A times D. That is always true. So for example, let's say you had 1/2 equals 5/10. You'd see 2 times 5, that's equal to 1 times 10. This is always true. If the fraction is true, this is always true. What books generally don't teach you specifically because they see it as a somewhat of a cheat understanding and you miss the math of it, but honestly, it's what everybody does. It's this concept of what we call move or swap. Let me back this up. So that means if you take the 2 and you move it over here and you replace it with a 1, this is also true. 5 times 2 is 10. 10 over 10 is 1 over 1. If I move B up to C, or I move C down to B, or I move A over to D, or D over to A, if I move them, it still remains true. And it doesn't matter which one you move. Understand, though, when you remove it, you have to replace with a 1. Otherwise, it won't make sense. So let's say I have 3, 6. That's equal to 1/2. Okay, move the 2 up here. So it goes away. Well, there's a 1 there. That's what I mean by that. 3 times 2 is 6. 6 over 6 is the same as 1 over 1. Okay, same thing. If I have 3, 6 equals 1/2, I can move the 3 down here. But I replace it with a 1. So 1/6 is 1 over 2 times 3. This is always true. Okay, second thing you can do is you can swap. So let's say I have 4/8 equals 1/2. I'm allowed to just swap along the diagonals. So this could be 2/8 equals 1/4. In other words, I switch the 2 with the 4, and I basically do this. So I move that one up there, move this one down there, and this is also true. 2/8 is 1/4. These are true. You can move and swap. Okay, so why do we do that, you ask? Well, I'm glad you asked, because this is a math lesson on why we do that and doing it and stuff. So here's the deal. Very often you will get a problem like, let's say, this one. 2/3 over x equals 5/8 over 1/5, and this just looks ugly. And you're saying, okay, what do I do? Well, what we want is x. So one of my goals is I'm just going to get x by itself. So I'm going to move it up there and swap it with, actually, I'm just going to swap it with this. So the x comes up there, and the 5/8 is down here. I'm going to move the 1/5 up here. So in other words, move that up there, replace it with a 1. I'm just going to leave it blank or leave a 1 there. And now I have x equals this thing. Well, okay, well, what's 2/3? I don't know. 2 times 1 is 2. This becomes 2/15 over 5/8. Okay, and that's x. Done. Now, I'm not completely done. We do know that when you have a fraction, it's the top divided by the bottom, which is 2/15 divided by 5/8. But we don't divide fractions. That becomes 2/15 times 8/5. So if you have a fraction divided by a fraction, we just make it multiplied times the reciprocal, and this becomes 16 over 75. 2 times 8 is 16, 15 times 5 is 75. That's what x is. You never would have guessed that. It seemed really hard, but what we really just did is you had an a, b, equals c over d, and we wanted to know what b was. So we moved the b up here, and we took the a and the d, moved the d up there, swapped the b and the c, and now I end up with, well, that's what that is. In this case, it was an x instead of a b. But these are the same basic 4 things. Move them, swap them, until you get the one you want on one side and then whatever else is left. And then once you have whatever else is left, you do the math. So that's pretty much the deal. So I'll do one more just so you can see it, because that one's now looking kind of ugly, and that was pretty fast. So let's do one that actually is part of your homework. This is practice problem, let's go A. You have 3/2 over 1/5 equals 1/4 over x. Okay, I want x by itself. So I'm going to move it this way and swap it with the, so in other words, I'm going to swap these two. I'm going to then move the 1/5 up there, and now I'm done. So that's x. Now I just have to do the math. And this becomes 1/20 over 3/2, which is 1/20 divided by 3/2, which is 1/20 times 2/3, which is 2 over 60, or 1 over 30. Answer. That's what you do. Move and swap till you get the thing by itself, then just do the math, as they say. And that is lesson number 59. Okay, on to lesson number 60. Lesson, let's try this again. Lesson 60. See, this is what happens when you are using the eraser function. All right. So, lesson 60, what is that? Circles. Circles is lesson 60. Lesson 60 is in a circle from the middle to the outside is called the radius. Okay? From going across to the middle, this is called the diameter. Sorry, that's the English version. Diameter, ER is the American version. And then going around the outside, it's called the circumference. So this is the basic deal. Now, what is you need to know? Now that you know these three words, there's two things you know. The area of a circle, that's how much is in it. Area is equal to pi times the radius squared. That's the area. So if you know the radius, you just take pi, which is 3.14, times the radius times the radius. That's what we mean by radius squared. That is a formula you need to know. Area equals pi r squared. Another way you can, or thing you can do, is you can find the circumference of a circle. The circumference is equal to 2 times pi times the radius. So if you know the radius, and you just take 2 times 3.14 times the radius, and that will give you the circumference. That's the second formula. That's this, how far around the circle you go. And so you'll have problems that deal with that, where you just need to know those formulas. And so I'll give you a really simple problem with that. So for example, if you say that the radius of a circle is 5 centimeters, and I say what's the area? Well, the area is pi r squared, or pi times 5 squared, or 25 pi. That's actually good enough as an answer. If you multiply that out with the 25 times 3.14, use a calculator, and it's somewhere around 78. This is okay. Just leave it with pi. Like, everybody knows pi is 3.14, and it means just multiply times that. If If I say, what's the circumference if the circle is that? Well, the circumference is equal to 2 pi r, or 2 pi, in this case, 5. So it is 10 pi, which is 10 times 3.14, or 31.4. Again, this is a good enough answer. This is a good enough answer. So that's all you'll have to do is they'll give you a radius, or they'll give you a diameter, in which the radius is half of that, and they'll say, find the area, find the circumference. That's lesson 60. Pretty easy. Let's move on to lesson 61. All right, lesson 61. Lesson 61 is solving equations in 2 steps. It is basically doing what you've been doing, only it's just not instantaneous, and they're fractioning. So let's say you have 2/3 x minus 1/6 equals 1/2. There's a couple ways to do this. This is taking a, let's do really simple. If I had 2x minus 1 equals 1, something like that, how would I do that one? Well, I would add 1 to both sides, and I would end up with 2x equals 2, and then I would divide both sides by 2, and I get x equals that, okay? And those we've been doing all year. But what's with fractions? It's kind of 2 approaches to this, and I'm okay with either approach. I think one is simpler than the other, so I'm going to do both. First one is I'm going to do just like what we did do before. I've got something times x minus something equals something. Well, if I add 1/6 to both sides, I get 2/3 x equals 1/2 plus 1/6. Well, I need a common denominator, so I'm going to multiply top and bottom of this one times 3, and I end up with 3 plus 1 over 6, or I get 4/6 equals 2/3 x. Now, to get x by itself, I want to make this number in front 1. To do that, I'm going to multiply times the reciprocal of this fraction. And if I do that to the left side, I must also do it to the right side, because 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1. I end up with x equals 4 times 3 over 6 times 2, or 12/12, which is 1. That's the answer to this original problem. Okay, and that's how you would do this original problem, just the way we've been doing them all along. I'm going to show you a different method, which you may like. You have to be very particular on when you use it, because not all problems are the same. But let's look at this. Notice my denominators are all different. I'm going to make these all common denominators. So I have a 3, a 6, and a 2. I'm going to make them all 6s. So I'm going to multiply top and bottom times 2. This one is already a 6, and multiply top and bottom times 3. What I'm going to end up with is 4x minus 1, 4x over 6, minus 1 over 6 equals 3 over 6. Notice that? If they're all over 6, or in other words, 4x minus 1 over 6 equals 3 over 6, that means the top of this one has to equal the top of that one. Well, 4x minus 1 equals 3. Add 1 to both sides, I get 4x equals, add 1, those go away, 4x equals 4, x equals 1. Notice it's the same answer as I did the long way, only this way, no fractions to deal with. I didn't have to add or multiply any fractions. All I had to do was get a common denominator. I like this method. I'm going to give you another example of this method, without explaining to you as much about, I actually would take a couple of steps out of it if I was doing this on my own, so it would even be faster. So, for example, let's say I have 2 and 1/2 x plus 1/8 equals 1/4. Okay, again, I could subtract 1/8 from both sides, but first thing I would do is make sure this is this. This is what I'm starting with. I never want to start with a mixed number. Bad, evil. Okay? So I'm going to do this getting a common denominator. To make this a common denominator, multiply top and bottom times 4. So now I have an 8, multiply top and bottom times 2. So now I have 4 times 5x, or 20x plus 1 equals 2. Subtract 1 from both sides. 20x equals 1, x equals 1/20. Notice how fast that is? I like this method rather than the alternate method. Again, alternate method was starting with 5 halves x plus 1/8 equals 1/4 would be subtract 1/8 from both sides, get a common denominator. This becomes 2 minus 1 over 8 equals 5 halves x, or that's equal to 1/8. And so I get 5 halves x equals 1/8. Multiply both sides times 2/5. And I end up with, whoa, whatever that was. And I end up with 1 times 2 is 2 40ths, or 1/20. Okay, notice this is a lot more fractiony than this top one is. Same answer. And if you're good at fractions, I can't do this as fast. It's like, this is fast, this is slow. I can do both reasonably fast and not have a problem with it. But I prefer this equation over that equation any day. So you can eliminate the fractions by simply getting the denominators the same and just do the numerators. That is an okie doke, legit way to do things. So that's lesson 61. Let's go to lesson 62 for the last one of the day. Okay, lesson 62. All right, lesson 62 is about fractional part word problems. Okay, what does that mean? The idea is that, I'll give you an example. It says, a race started, 2/5 of the racers begin to run. There's 460 of these kids run. So how many total racers? Okay, so what you're looking at is 2/5 of the total is 460, right? Do you recognize blank of blank is blank? So in this particular problem, what you're doing is you are rewriting the kind of information into a math sentence, of which we know that means 2/5 of means times. We don't know this, so we'll give it x, equals 460. Okay, now just multiply both sides times 5 halves. Those go away, and that equals 230 times 5, which is 1,150 total racers. So you can do that with your calculator if you like. But I'm taking my information and it goes into the form of this is this. This was practice problem A. Let me give you another one. And so you can kind of see that this is kind of a pattern that you can follow. All right, so for example, the fog lifted. This is an example on page 198. Example. Okay, it says the fog lifted and there were 400 ghosts were spied near the outskirts of the whatever. Now, there were 240 ghosts were not spied. So these were spied. These were, in other words, you saw them. And this one, you didn't see him. Okay, so what fractions were not spied? Well, do we know anything? Well, sure. We know 240 is what percent of the total? Okay, well, do you notice? Blank of blank is blank. Okay, do we know the total? Sure, if there's 400 spied and 240 not spied, we know the total is 640. So we have 240 equals x, the one we don't know, times 640. Divide both sides by 640. And I end up with x equals whatever that is, 240 over 640. And I take my handy dandy calculator out and I say, I don't know, what's 240 divided by 640? And the answer is it's 0.375. So 37.5% were not spied. So that's how we do it. You're basically trading your word sentence into this of this is this. Okay, and that's lesson number 62. And I will see you next week.